Mobile games are going big. Play the official PC version of Clash of Clans with Google Play Games. Download and play today.
Now, this video is for those of you who are taking the Calculus 1 final exam. That is if you're in college, or if you're in high school, you can also use this if you're taking the AP Calculus exam. You can benefit from this video as well. So this video is going to cover continuity, limits, derivatives, integration, and all the subtopics in those topics. So let's go ahead and begin. Number 1, evaluate the limit shown. Now, it's always good to see if you can use direct substitution. However, if we plug in 3, we're going to get 9 squared minus 9, which will give us 0 in the denominator. So we can't use direct substitution. In this case, what we need to do first is we need to factor the expression. So to factor a difference of perfect squares, x squared minus 9, we can write that as x plus 3 times x minus 3. The square root of x squared is x, and the square root of 9 is 3. And so that's how you can get those numbers. Now, what about factoring this trinomial? What two numbers multiply to negative 15, but add to positive 2? So this is going to be positive 5 and negative 3. 5 plus negative 3 adds up to 2. 5 times negative 3 multiplies to negative 15. So at this point, we could cancel the x minus 3 factor. And so what we have left over is the limit as x approaches 3 of x plus 5 over x plus 3. So now at this point, we could use direct substitution. So it's going to be 3 plus 5 divided by 3 plus 3. 3 plus 5 is 8, 3 plus 3 is 6. And then if you divide both numbers by 2, you can reduce that. So A is the correct answer. Now let's move on to number 2. Evaluate the expression shown below. So for each of these problems, pause the video and work on it. And then when you're ready, just hit the play button and see if you have the right answer. Now for this problem, you need to be familiar with the power rule. The derivative of a variable raised to a constant, such as x to the n, it's going to be that constant times the variable raised to the constant minus 1. So just to review, the derivative of x to the 4th power is going to be, in this case n is 4, 4x to the 4 minus 1, which is 4x cubed. So now let's try this problem. So what we're going to do is differentiate each one individually. The derivative of x to the 6th power is going to be 6 x to the 6 minus 1, which is 5. Now, for 3 over x, we need to rewrite it. If we move the variable to the top, it becomes 3x to the minus 1. And so now we can use the power rule. So the derivative of x to the minus 1 is going to be negative 1 x to the negative 1 minus 1, which is negative 2. Now, the square root of x, we also need to rewrite it. And we can rewrite it as x to the 1/2. So using the power rule, it's going to be 1/2 x, and then it's going to be 1/2 minus 1. So far we have 6x to the 5th power, minus 3x to the minus 2, and then 1/2 minus 1. Negative 1 is the same as negative 2 over 2. So 1 minus 2 is negative 1. So 1/2 minus 1 is negative 1/2. Now we need to get rid of the negative exponents. And so what we can do is bring the variable back to the bottom. And the negative exponent is going to change to a positive exponent. So this is going to be negative 3 over x squared. And this is going to be plus 1. The 2 is already on the bottom. Now we need to move the x variable to the bottom. And so that's going to be x to the positive 1/2. Now x to the 1/2 is the same as the square root of x. So instead of writing x to the 1/2, we can write the square root of x here. Thus, this is the final answer. Number 3. Find the value of c that makes f of x continuous. To make the piecewise function continuous, the two parts of the piecewise function must be equal to each other when x is equal to 3. So step 1, set these two parts equal to each other. So we're going to have 2cx minus 6 is equal to x squared plus cx. Now, the next thing we need to do is replace x with 3. So it's going to be 2c times 3 minus 6 is equal to 3 squared plus c times 3. At this point, we only have one variable in the equation, which is c, so we can solve for it. 2 times 3 is 6, so on the left side we have 6c minus 6, 3 squared is 9, so we have 9 plus 3c on the right side. Now let's subtract both sides by 3c, and at the same time, let's add 6 to both sides. So we can cancel this and that. So here we have 6c minus 3c, which is 3c, and then 9 plus 6, that's 15. Dividing both sides by 3, we'll just have it there. Let's fix that.
What? Still searching YouTube for math help? Are the videos from 2006
We get 15 over 3, which is 5. And so that's the answer. C is equal to 5. So that's the value of c that makes f of x continuous. So E is the correct.
Set them equal to each other.
Correct answers. Number 4. Find the derivative of the expression shown below.
E to the 4x times ln 2x plus 1.
Now there's 3 things that you need to know in order to do this problem. You need to know how to differentiate exponential functions, logarithmic functions, and you need to know how to use the product rule. So let's talk about how to find the derivative of exponential functions. The derivative of e to the u, where u is a function of x, is going to be the same thing, e to the u times u prime. So let's say if I wanted to differentiate e to the x squared, it's going to be e to the x squared times the derivative of x squared, which is 2x.
So e to the x of e to x squared would be e to the x squared times 2x, because find
Or, let's say if I want to differentiate e to the 7x, it's going to be e to the 7x times the derivative of 7x, which is 7. Now let's talk about how to differentiate logarithmic functions, specifically natural log functions. The derivative of ln u with respect to x is going to be u prime divided by u. So let's say if...
Okay, and so then that's going to go for the log, and then ln's going to be blue. So d over dx ln u equals u prime over u.
I want to differentiate ln(x). So u is x. The derivative of x is 1. And since u is x, that's going to be x in the bottom, so we get 1 over x. Now let's say if I have the derivative of ln x squared plus 7. The derivative of x squared plus 7 is 2x. On the bottom, whatever is inside the natural log expression, we just need to rewrite that on the bottom. So it's going to be 2x over x squared plus 7.
So 2x over x squared plus 7. So let me break this down. X, because the 7 goes away, 7 goes away, and then over the original, so we've had 1, 2, 3, 4, 5, 6, 9.
Now let's talk about the product rule. The derivative of, let's say we have two things multiplied to each other, f times g, it's going to be the derivative of the first part.
Product rule, so d over dx f times g equals, I think it's f prime.
So that's f prime,
yeah,
times the second part, which is g, plus the first part times the derivative of the second.
G part. Okay.
So let's say that f is e to the 4x. So what's f prime going to be?
F.
Using the equation that we had before, it's e to the u times u prime. So it's going to be e to the 4x times the derivative of 4x, which is 4. Now g is going to be the second part of that expression. So that's ln 2x plus 5.
Okay, so ln 2x plus 5, and then you're going to find the derivative of... Okay. So g is equal to ln parentheses 2x plus 5. So we're still in this problem. Right there. Doing this problem. And so that's where the ln is from. Okay. And so he's giving us the e to the 4x ln, that's our g, and then we're going to find the derivative of, so g prime would be,
Now g prime, using the formula u prime over u, it's going to be the derivative of 2x plus 5, which is just 2, divided by whatever is inside the natural log expression.
which is 2x plus
So
5.
that's 2x plus 5. So now, all we need to do is follow this formula.
So then f,
So the derivative of this expression is going to be f prime, which is 4 e to the 4x,
4,
and then times g, so that's ln 2x plus 5, and then plus,
that would be e to the 4 times 4, so that just goes forward, 4 e to the 4x times g, which is ln of 2x plus 5
f, which is e to the 4x,
plus e
times
plus
g prime, which is that 2 over 2x plus
2x plus
5.
5.
Now we can basically combine those two. So I'm going to rewrite this as 2 e to the 4x over 2x plus 5. So we can leave our final answer like this. And so that's it for this problem.
Wait, 2e. Huh. Okay. So then you rewrite it as, let's do it in white. 4e to the 4x times ln, parentheses 2x plus 5, plus 2e to the 4x over 2x plus 5. That makes sense. Okay, let me get a sticky note. So right now we're at 10. Okay, we've done 10 calculus problems. I'll update it.
Number 5, evaluate the following integral.
Whoa.
Now I do want to mention a few things before we start this problem. One is to check the links in the description section below. I'm going to post a few links to some other videos, like on limits, derivatives, and integration, for those of you who need more example problems.
Not gonna lie.
I'm also going to place a link to our House playlist. Let's say if you need help with a specific topic and you don't see it in this exam. So feel free to take a look at that when you get a chance. Now these problems may seem simple to you, but they will get harder as we progress in this video. But let's start with this one. So how can we evaluate the following integral? What is the antiderivative of 4x to the 5th plus x to the 4th minus 3x cubed, minus 3x?
So find the end. So plus 4x to the 5 plus x to the 4 minus 3x squared over x squared dx.
X squared divided by x squared. What we need to do is simplify the expression first. So let's begin by dividing each term in the numerator of the fraction by x squared. So x to the 5th divided by x squared is going to be x cubed times 4. because 5 minus 2 is 3. Now, x to the 4th divided by x squared is x squared. 4 minus 2 is 2.
Okay, so S B 4x 4x to the third plus x squared so minus 3.
And then negative 3x squared divided by x squared. The x squared stuff will cancel.
Yeah.
And so it's going to be negative 3.
Negative.
Now, we have to use the power rule version for integration. So just to review, we said that the derivative of a variable raised to a constant is going to be the constant times the variable raised to the constant minus 1.
Power rule.
The antiderivative of x to the n is...
Okay, so let's write this in purple. So d over dx, x to the n equals nx minus 1 basic power rule. Power rule. So we know that one. So now you have x to the n times dx.
It's going to be... So instead of subtracting 1, we're going to add 1 to the constant, and then we're going to divide by that result. And don't forget to add the constant integration. So this is the power rule when dealing with integration. Add 1 and then divide by that result.
So add 1, then divide by the result.
So what is the antiderivative of x cubed? The constant in front, just rewrite it. So what we're going to do to find the antiderivative of x cubed is add 1 to the exponent. 3 plus 1 is 4, and then divide by that number.
4x.
Here we're going to do the same. 2 plus 1 is 3, and then divide by 3.
X cubed.
Now the antiderivative of negative 3 is simply negative 3x. Negative 3 is the same as just negative 3 times x to the 0, because anything raised to the 0 power is 1. And so you can think of it this way. If we add 1 to 0 and then divide by the result, we're going to get negative 3x. So that's the antiderivative of negative 3. Now the next thing we need to do is add the constant of integration. Finally, we need to simplify our answer. So we could cancel the 4, and so we're going to have x to the 4th plus, we can write this as 1/3 x cubed, and then minus 3x plus c. So this is the final answer for the problem. So that's how we can evaluate this particular interval. Number 6. Find the equation of the tangent line to the curve x cubed plus 4xy squared plus y cubed equals 107. At the point 2, 3, using implicit differentiation. So now let's talk about this. Let's say if we have some generic curve. It may not be this exact curve. The tangent line is a line that touches the curve at exactly 1 point. A secant line touches the curve at 2 points. Now, in order to find the...
Wait, so he said tangent line touches 1 point. touches that too.
The equation of the tangent line. We need three things.
So this one says find the equation. Alright, let me write this right. The equation. Find the equation of the tangent line to the curve x cubed plus 4x y squared plus y cubed equals 107 at 2 using implicit differentiation.
We need the x and y coordinates of this point of intersection, which we have already, and we need the slope of the tangent line, which we do not have.
We are going to attack crime in the city of Houston. Someone puts a gun in your face.
Now, the slope of the tangent line is equal to the first derivative of the function at some x value.
So, let me draw this out. So we have that. Looking for P, X, Y, and tan equals X.
In this particular problem, it's going to equal dy dx at the point 2, 3. So, we need to use implicit differentiation to find dy dx. Plug in this point, that will give us the slope of the tangent line, and then we can use the point slope formula to write the equation of the tangent line. So let's go ahead and begin. Let's start by differentiating this expression with respect to x. The derivative of x cubed with respect to x is 3x squared. Now for this expression, 4x y squared, we need to use the product rule. So let's say f is 4x and g is y squared. Now the basic idea behind the product rule is that you differentiate the first part of the function, the derivative of 4x is 4, and then you leave the second part alone. So that's going to be y squared. And then plus. Now, we're going to leave the first part alone and then differentiate the second part. The derivative of y squared with respect to x,
2y.
be careful with this, it's 2y times dy dx. So remember, when dealing with implicit differentiation, every time you differentiate a y variable with respect to x, you need to add dy dx to it. The derivative of y cubed is 3y squared times dy dx. And the derivative of a constant, 107, is 0. Now at this point, we do not need to isolate dy dx. In fact, to make it easier, I recommend replacing x and y with their respective values. So let's replace x with 2, and let's replace y with 3. And then let's calculate the value of dy dx. Two squared is 4 times 3, that's 12. 3 squared is 9 times 4 is 36. 4 times 2 is 8. 2 times 3 is 6. 3 squared is 9 times 3, that's 27. So right now we can add these two. 12 plus 36 is 48. And if we move that to the other side of the equation, it's going to be negative 48 on this side. Now, 8 times 6 is 48. And then we have plus 27 divided by x. So at this point, we can get rid of this stuff. Since we have like terms, we can add these two numbers. 48 plus 27. 40 plus 20 is 60. 8 plus 7 is 15. 60 plus 15 is 75. So we have 75 divided by x, and that's equal to negative 48. So now we can divide both sides by 75. So dy dx is equal to negative 48 over 75 when x is 2 and when y is 3. So this is equal to the slope of the tangent line at that point. So now we have enough information to write the equation of the tangent line. So we're going to use the point slope formula. Y minus y1 is equal to m times x minus x1. y1 is 3, x1 is 2. So this is going to be y minus 3 is equal to m is negative 48 over 75. But we can reduce that. Let's divide the top and the bottom by 3. So this is negative 16 over 25. So let's replace m with that. Now x1 is 2. So this is the equation of the tangent line in point slope form. So if this was a free response problem, you could leave your answer like this, and you'll be done with it. But this is a multiple choice problem. And looking at the answers, all of them are in standard form. Now sometimes you may need to solve for y. Sometimes the answers may be in slope-intercept form, y equals mx plus b. But we need to get it in this form first. So how can we do that? One thing I recommend doing is getting rid of the fraction, because we don't have that anywhere in any of the answer choices. So let's multiply both sides by 25. So on the right side,
So
these two are canceled. On the left side, we're going to have 25y minus 75. And then it's going to be negative 16x, and then negative 16 times negative 2, that's a positive 32. Now let's rearrange what we have. I'm going to move the negative 16x from the right side to the left side. So on the left side, it's going to be positive 16x, and then we're going to have plus 25y. Now the negative 75, I'm going to move it to this side. On the right side, it's going to be positive 75. So 32 plus positive 75 is positive 107. So this is the answer. 16x plus 25y equals 107. That is the equation of the tangent line in standard form. And so this matches answer choice D. Number 7. Which of the following answer choices is equivalent to the expression shown below? So go ahead and think about it. Work out this problem. Now, there's really no way in which we can work out this limit. We have no numbers to plug in. There's nothing to factor.
limit as h of 0.
We can't rationalize the denominator or get any common denominators. None of that. The only way to find the answer to this problem is to understand what it really means. You need to know that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h.
Okay. F of x is equal to, remember, as h equals 0, x plus h minus f x over h. I think this is the, this might be the basic limit formula, like by definition. So, which of the following answer choices? I need to review over the tangent and whatnot. Let's see.
So this entire thing is equal to f prime of x, and that's what you're looking for. So what is f prime of x? Because that's going to give us the answer to this entire expression. Now first we need to know what f of x is.
Mobile games are going big. Clash of Clans is now available on PC with Google Play Games.
Clash of Clans available on PC.
Notice that f of x lines up with sine x. So if f of x is sine x, what's f prime of x? The derivative of sine x is cosine x.
Okay, so you want to break it up.
And so this is the answer. This entire thing is equal to cosine x. So A is the right answer. Now let's work on number 8.
Cosine x.
Evaluate the integral shown below. So how can we do this? We can't use the power rule for this example, but we could use something known as U substitution.
U substitution, okay. Problem with U substitution. Okay. So okay. Integral of 2x square root 3x squared plus 5 dx.
What we're going to do is make U equal to 3x squared plus 5. And so du is going to be the derivative of that, which is 6x times dx. The derivative of a constant is 0. Now, what I recommend doing is dividing both sides by 6x to solve for dx. So dx is going to be du divided by 6x. In the next step, we're going to replace 3x squared plus 5 with the u variable.
The u variable, because that's what u is. Okay, so let's go to white. So the integral 2x u,
And at the same time, we're going to replace the dx
with
what we have here.
du over x.
So that's du over 6x. So notice that all of the x variables have been canceled. 2 over 6, we can reduce that to 1 over 3. And I'm going to move the constant in front. The square root of u is the same as u to the 1/2. So now we can find the antiderivative of u to the 1/2. So we need to add 1 to it. 1/2 plus 1 is 3 over 2. And then instead of dividing by 3 over 2, we can multiply by the reciprocal, 2 over 3. And don't forget to put plus c. So multiplying these two fractions, it's going to give us 2 over 9, and then we'll have u to the 3/2 plus c. Now our next step is to replace u with
3x.
what we have here, 3x squared plus 5. So the final answer is 2 over 9, 3x squared plus 5, raised to the 3 over 2 plus c. So that's how you can use u substitution to find the antiderivative of certain functions.
Okay, so what he did was first write u and du, and then 3x squared plus 5x, 6x is the du dx, divided by 6x, plug it back into the old formula for u. Okay, and then plug back in u, which is 3x squared plus 5 into u. Okay.
Number 9. Water is flowing into a cylinder with a diameter of 6 feet and the height of 10 feet.
Oh,
If the height of the water...
this is a related rates problem. Okay, so 14.
water in the cylinder.
So this is related rates. Related rates
Is increasing at 3 feet per minute. At what rate is the volume of the water in the cylinder changing? Now, for those of you who want harder related rates problems, you can check out the videos that I have on YouTube. So what I recommend doing is going to the search box and type in, you're going to see, let's draw a picture. So we know the diameter of the cylinder, so that's 6 feet, which means the radius of the cylinder has to be half of that.
So let's write this out though real quick. Water is flowing into a cylinder with a diameter of 6 feet and a height of 10 feet. The height of the water in the cylinder is increasing at 3 feet a minute. What rate is the volume of the cylinder? Okay. What rate is changing?
So the radius is 3 feet.
So you narrow it out.
The height of the cylinder is 10 feet. Now we have some water in the cylinder, and more water is entering the cylinder. Now we know the height of the water in the cylinder is increasing at a rate of 3 feet per minute. So what variable does that represent? So this is the rate at which the height is changing with respect to time. So it's 3 feet per minute. And it's positive because it's increasing. Now the next thing we need to do is write the formula for this situation. So we're dealing with volume and cylinder. So what is the volume of a cylinder? The volume of a cylinder is equal to the area of the base times the height of the cylinder. And the base is a circle. The area of a circle is pi r squared. So the volume is pi r squared times height. Now, we need to know which letters are constants and which ones are variables. So V, the volume, would you say it's a variable or a constant? In this case, V is a variable because the volume of the water in the cylinder is changing, it's not constant. Pi is a constant, it's always 3.14. Now what about the radius of the water in the cylinder? Is that constant? Imagine the cylinder being filled up with water. Will the radius of the water change? Now we know that liquids, they take up the shape of their container. So because the radius of the cylinder is always 3 feet, the radius of the water in the cylinder will always be 3 feet. So the radius is a constant. So pi r squared, that whole expression is a constant. Now the height of the water is changing because as you add water, the water level will rise. So h is a variable. Now this is important because when you're dealing with related rates, you're not differentiating with respect to x as you would using implicit differentiation. You're differentiating with respect to time. And the only thing you need to worry about are the variables, not the constants. Because if r was changing, when we differentiate it, we would have to use the product rule. But because this is a constant, we do not have to use the product rule. It's the same as differentiating 5x. You wouldn't use the product rule for that, or 8x cubed. You don't use the product rule for that. But if you have like x cubed times y squared, where both of these are variables, then you need to use the product rule. But let's say if x was a constant and y was a variable, then you do not have to use the product rule. You only need to use the product rule if you have two different variables being multiplied. Or if you have two variable expressions of the same type. So e to the 4x, that's also times the variable. Now, what is the derivative of pi r squared times h with respect to time? If we were to differentiate 5h, it would simply be 5 times dh dt. The derivative of pi r squared times h will thus be pi r squared, and the derivative of h is 1, and then times dh dt. So this is a constant like 5, so we just need to rewrite it. Now we have everything that we need. Get the answer. our goal is to calculate dVdt. R doesn't change. R is going to be 3 feet. And the HDT, that's changing at 3 feet per minute. So 3 squared times 3, that's 27. Thus the answer is going to be 27 pi. Now, what are the units of dVdt? Because you also need to get that right. The unit for h, height, would be like feet, meters, things like that. Now for volume, it's like cubic feet, cubic meters, cubic inches. So in this case, it's cubic feet, since h is in feet. Now the time, dt, is in minutes. So this is going to be the same. That's going to be in minutes as well. Thus it's 27 pi cubic feet per minute.
Last year, Cyber broke all these fab sales records because of my irresponsible offer. 7%.
Number 10. Identify all intervals where the function f of x is increasing, given f.
Yo, chat. This is how you stream, bro. You stream your settings so your mom don't get mad. and I'm doing a calculus problem counter. So after every so minutes, I got a tally, and I'm just gonna update. I want to see if I can get to 100 problems or more. That's why it makes it fun. Although I don't know if it's legal to stream another YouTube video. Can you? I think I've seen streamers watch and react to other. So I think it's fine. I think we're fine.
F of x is equal to x cubed plus 3 over 2.
Oh, I like these problems. Okay, so I've done 15 so far, but once I get to like actual worksheets, I'm about to get So this one says identify all the intervals where f of x is increasing given. Okay. I'm gonna try to solve this. Do I remember this? Let's see. I could really do this. Hold on. Oh, I have an idea. What was it? Identify. Identify. Shoot. No. Identify any intervals where f x is increasing given given can I change the color? There we go. Given no. Given f of x is equal to x cubed plus 3 halves x squared minus 36x minus 9.
2x squared minus 36x minus 9.
I think you can find the derivatives for
So in order to find the intervals where the function is increasing, we need to identify the critical points. And one way we can do that is by finding the first derivative and setting it equal to 0.
Okay, so find critical points. Find first derivative, set equal to 0.
Then solve for x.
Okay, so this will be...
So let's do that. The derivative of x cubed is 3x squared. The derivative of x squared is 2x. The derivative of x is 1. And the derivative of a constant is 0. So we have 3x squared, and then the 2's will cancel, so this is going to be plus 3x minus 36. So let's set this equal to 0. Now, we can take out the GCF,
Okay.
the greatest common factor. So if we take out a 3, we're going to have x squared plus x minus 12. Now, let's factor the trinomial.
Okay.
What two numbers multiply to negative 12, but add to 1? So this is going to be positive 4 and negative 3. 4 plus negative 3 is positive 1, and 4 times negative 3 is negative 12.
Okay.
Now, what we need to do at this point is set each factor equal to 0.
So then
If you
it's
set
going
x plus 4 equal to 0, the critical point that you'll get
Negative
will be
4.
negative 4. And if you set x minus 3 equal to 0,
plus 3.
you'll get the critical point positive 3.
Okay.
So now what we need to do is make a number line
Draw number
by
line.
putting these critical.
Then draw number line. Oh, and then you said it. Oh, I remember this. Okay. Number.
Critical points on it. Next, we need to check the size. So let's pick a number greater than 3. Let's say 5. If we plug in 5 into this expression, into the first derivative, will we get a positive number or a negative number? Now, 5 minus 3 is a positive number. 5 plus 4 is a positive number. And this is positive. So the result will be positive. Now, what if we pick a number between negative 4 and 3, like 0?
0. So
Will
0
it be positive or negative?
negative.
0 minus 3 is negative.
Negative 3.
0 plus 4 is positive. A positive number times a negative number
Negative
will give
number.
us a negative result.
Okay.
Now, let's pick something less than negative 4, like negative 5. Negative 5 plus 4 is negative. Negative 5 minus 3 is a negative number. A negative times a negative number will give us a positive number.
So a positive.
All the way to the left will have negative infinity, and to the right, positive infinity.
Okay.
Now, let's get rid of this.
So we're
One thing I do want to mention is
increasing.
that whenever the first derivative is equal to a positive number, the function f of x is increasing.
So f of x equal to positive f of x is increasing.
Whenever the first derivative is equal to a negative number, so you have a negative slope, then the function is decreasing. So these are the signs for the first derivative. So the function is increasing between negative infinity and negative 4, and it's also increasing between 3 and infinity. It's decreasing between negative 4 and 3. So the answer, we could say the function is increasing. Between negative 4, between negative infinity to negative 4, union, and then between 3 and infinity. So this is the answer to the problem. Now, something I do want to mention is that you could use this to determine the location of any relative maximum or relative minimum. Some textbooks might use the term local maximum or local minimum. So here, the function is increasing, and then it's decreasing. So this looks like the local maximum. Here it's decreasing, and then increasing. So this looks like the local minimum. So that's how you can identify the relative extremity. on a function using the same process.
Okay. Alright, chat, let's try to solve this one. So, this says identify the local. Hey, if you want the light on, if it's too dark, you can turn it on.
I'm good.
You good? Okay. Identify. Here, let me write this. Let me type this out. Identify the location and maximum value of the function of x is equal to oopsies. Is equal to 16x minus x squared plus 5. Okay.
Number 11. Identify the...
Okay, let's try to solve this one. So we have 16x. First, let's find the derivative. So, okay. F of x is equal to 16x minus x squared plus 5. And prime of that's going to be f prime of x is equal to 16 minus 2x. Then we can factor out the 2, so that's going to be 2 parentheses x 2 x minus 8, set that equal to 0. Critical point equals 8 question mark?
Locate. And so this is our critical point. X is just bit, that's just net. If we add x to both sides, x is 8.
Okay.
So critical point is 8. So I have to plot this one.
Alright, so we got that right. It's another problem for the OGs.
Number 9. And let's say if you pick a number that's greater than 8, like 9.
9.
8 minus 9 is negative.
Negative 1.
If we plug in something less than 8, like 7, 8 minus 7 is positive.
Positive.
So whenever the signs alternate from positive to negative or left to right, you have a maximum. It's increasing and then it's decreasing. So we have a local max at 8.
8.
Now all we need to do to find the y coordinate is plug in the x value. So f of 8 is going to be 16 times 8 minus 8.
Oh, okay, so to find y value, plug in 8 to equation, derivative? Wait, f of 8 minus
8 squared plus 5. Now,
oh, okay, plug it into original. So that'll be 16 times 8 minus 8 squared plus 5.
now 16 times 8. 10 times 8 is 80, 6 times 8 is 48. So 80 plus 48, that's 128. H squared is 64. 128 minus 64 is 64. And 64 plus 5 is 69. Now, in case this problem was a free response problem and not a multiple choice, you need to know that this is the maximum value of the function, the y-coordinate. Now, the location of the maximum value is located at the x-coordinate, or at x equals 8. So if they ask you for the location of the critical point or the maximum value, this is your answer. If they ask you for the maximum value itself, this is your answer. So the function has a maximum value of 69. So B is the right answer for this problem. Now let's move on to 12. Calculate the average value of the function f of x is equal to x cubed.
Calculate the average value.
Plus 8x minus 4 over the interval 1 to 5. So here's the basic idea.
Calculate the average value of the interval. Calculate. Calculate the average value of the function f of x f of x equal to 1,5. Alright.
Idea behind calculating the average value. So let's say we have some generic function f of x. So basically what we're doing is we're taking the area under the curve and we're going to divide it by basically the width of the interval, which is an x value, and that's going to give us an average y value. So our goal is to calculate this average y value of the function.
This is your brain when you're struggling to focus. And this is your brain when you're in the zone.
So here's the formula that we need. The average function value, or the average y value, is going to be 1 divided by the width of the interval times the area under the curve in that interval, which is the definite integral from a to b of f of x dx. So this right here represents the area under the curve, and this portion represents the width of the interval, which as I said is the x value. And that will give us the average function value. So what is a and what is b? A, as we can see, is 1, b is 5. So this is going to be 1 over 5 minus 1 times the definite integral from 1 to 5, and then the function is x cubed plus 8.
Wait. Oh, I get it. B to A to B, 1 to 5. So this is the formula. Okay, so it's going to be 1. This 1. Because it's an integral.
8x minus 4 dx. 5 minus 1 is 4, so this becomes 1 over 4. Now we need to find the antiderivative of that expression. The antiderivative of x cubed is x to the 4th divided by 4.
So x 4 divided by 4 because you're adding 1.
And for 8x, it's going to be 8x squared divided by 2, which is 4x squared. And the antiderivative of
x
negative 4 is going to be negative 4. Now, we need to evaluate this from 1 to 5. Now, before we do so, it might be advantageous to distribute the 1/4 to everything inside the brackets. So it's going to be 1 over 16 times x to the 4th, and then these 4's will cancel. So that's going to be plus x squared, and these 4's will cancel as well, so minus x, evaluated from 1 to 5. So first, let's plug in 5. So it's going to be 1 over 16 times 5 to the 4th power, and then plus 5 squared minus 5, and then we can plug in 1. So it's going to be 1 over 16 plus 1 minus 1. Now 5 to the 4th power, that's 625.
But how am I supposed to do that without a calculator on it?
5 squared is 25, and then we have negative 1 over 16, and 1 minus 1 is 0. Now 625 over 16 minus 1 over 16, that becomes 624 over 16. And 25 minus 5 is 20. Now 624 divided by 16, that's 39. So it's 39 plus 20, which is 59. So this is the average line value of the function over the interval 1 to 5. Therefore, C is the right answer. Number 13.
Evaluate the expression shown below. Okay. Okay. 5, 10, 15, I'm almost at 20.
Evaluate the expression shown below. So what is the derivative of 2x cubed minus 7x squared raised to the 8th power? For this problem, we need to use something called a chain rule. Perhaps you've seen it expressed this way. The derivative of a composite function, let's say f of g of x, is going to be f prime of g of x times g prime of x. So notice that
So write that chain rule. Okay, d over dx. G of x times g prime of x.
that we differentiate the outside portion of the function, keeping the inside the same, and then we're going to multiply by the derivative of the inside of the function. We're going to follow that same process to differentiate this expression. So think of the outside portion of the function as x to the 8. That's like f of x. And think of the inside function g of x as being 2x cubed minus 7x squared. So let's differentiate the outside portion. The derivative of x to the 8 would be 8x to the 7th power. So what we're going to do is we're going to move the 8 to the front.
So
Now, instead of writing x, we're going to keep everything that we have on
this
the inside. Exactly the
8x
same.
cubed minus 7x squared to the 7.
And then we're going to subtract this by 1. So that's going to be 7. Next, we're going to take the derivative of the inside function
So
to get our g prime.
6x squared.
So the derivative of 2x cubed is 6x squared, and the derivative of 7x squared is 14x. And since this is a free response question, we can leave our answer like this.
Okay, I bet.
Now, for those of you who may want to simplify the answer, we could take out the GCF in this expression. So we could take out...
Okay.
out 2x. So multiplying 8 by 2x, that's going to give us 16x. And then we have 2x cubed minus 7x squared raised to the 7th power. And now that we've taken out 2x, we need to divide everything down by 2x. 6x squared divided by 2x is 3x. Negative 14x divided by 2x is negative 7. So you could leave your answer like this if you want to. So that's how you could use the chain rule. Now, for those of you who want more examples on the chain rule, particularly the chain, you need number 14. Evaluate the limit expression shown below. Now, let's say if you get a limit problem like this, and you have no idea what to do. It turns out that you can evaluate any limit if you have access to a calculator, if that is allowed in the test. If it's a free response problem and you can't use a calculator, you just have to know the techniques involved. But let's say if you do have access to a calculator, what you could do is plug in a number that's close to 4.
Mobile games are going big.
Six, 0, 9. Note something. So we would 6. Now, in fraction by might. Now, let's distribute the 4x. So 4x times 1 over x. The x variables will cancel, and so we're just going to get 4 on top. Now, 4x times 1/4, the 4's will cancel,
1.
and so we're just going to get negative x on top. And on the bottom, don't distribute, just rewrite it as 4x times x minus 4. Now, what's our next step here? What do you think we need to do at this point? What I recommend doing is factoring out a negative 1 from 4 minus x. If you take out a negative 1 from negative x, negative x changes to positive x. And if you take out a negative 1 from positive 4, it becomes negative 4. So notice that we can cancel x minus 4. So now we have the limit as x approaches 4 for negative 1 over 4x. So now we can use direct substitution. So replacing x with 4, we're going to get negative 1 over 16. So this is the final answer. Answer choice D. Number 15. Identify all intervals. Answer choice D. Number 15. Identify all intervals where the function f of x is concave downward. Now before we attempt this, problem. Let's write down some notes. Let's summarize what we need to know.
Identify all intervals where the function is concave down. Okay, let's solve this one. Let's see. Find when concave down at f of x cubed minus 6x squared plus 5x plus 1. So f prime of x equals 3x squared minus 12x plus 5 negative 12x
When the first derivative and what's an f equal, what about the function f of x is said to be concave down? And when it's equal to 0, f of x has an inflection point if the concavity changes. That is, if it doesn't equal a problem, we are concerned.
Hold on, let's write this down real quick. So f prime of x positive means f of x increases negative f x decreases f of x equals 0, critical point, f prime of x equals positive, f of x is concave up if f double prime of x negative, x is concave down, if f prime of x is 0, f of x infinite.
Sorry, with this information. So let's go ahead and find the second derivative and set it equal to 0. Let's start with the first derivative.
Oh, that's
F
why I have to
prime
find the second derivative. I'm
The
so
derivative
dumb.
of x cubed is 3x squared.
6x
The derivative of
minus
x squared
12
is 2x
Oh,
times.
okay, I mean, shoot. So then factor out the 6. So we 6 parentheses x minus 2 equal to 0. Critical point equals 2. I'll draw a number line at 2. Plug 3 into the original. 1 negative, so it's positive, negative.
Is negative 6, that's minus 2 is positive.
Yep.
Is an inflection point because the
the
concavity, the second derivative, changes sign. On the left side, the second derivative is negative, which means that the function is concave down. On the right side, because the second derivative is positive, it's concave up. So for this particular problem, the interval where the function is concave down is from negative infinity to 2. So that's when the second derivative is negative.
Easy. Alright, let's add another. Or if I had double monitor, I could just pull that thing out to the side. I won't have to worry about doing this, but 22. Okay, hold up. I'm gonna.
This holiday season at PetSmart, buy 3 dog treats and get the 4th free. Plus, earn double the points.
Okay, hold up. Let's see. Now we gotta. Should we do a practice quiz?
What's going on, guys? In this video, we're going to be doing part 1 of our Calculus 1 final review. In this video, we'll be covering limits, and then we're going to be talking about...
Yo, chat. What do we do? Hold on, I'm not sharing my screen yet. Should we do a... Let's do a practice test. Let me log in though real quick. I'll show the screen when I'm done. Oh. One sec. I'm at the time now. Okay. Let's do a practice test. Take. Okay. Alright. Let's take this practice test. Practice test. So 1 cube 1. We'd have to do HalfMileHaughty 12. Oh, sorry. Okay. So limit and x equals 1. Minus 1. Bro, okay. 1 cube 1 would be 0 over 0. So then 3x over 1 it should just equal 3. Which of the following best represents f prime? Oh, this is the limit. Okay. Oh, I forgot this. Okay. This is just the basic limit rule. Which of the following wait 1 sec. Chat, GG's, GG's. The graph of the function was shown. F prime 1. We'll go back to that one. Related rates. This is scary. Uh-oh. I'm definitely doing this wrong. No chat, we're like getting fried. Just a quiz, just a quiz. Should we watch another?
Derivatives, kind of like, all the different rules with derivatives. We'll be talking about some things that we can do with derivatives, and in the next video, in the part 2 video, that'll be the last video only with this two-parter, we're going to be doing the applications of derivatives, right? So we're going to be doing things like optimization, finding mins and maxes, different things like that, right? And we'll also be talking about integral. girls. Alright? So, let's get into more of what we're going to be doing in this video. So, you can see I have all the timestamps for what we're going to be doing.
Chat. No, I really have to wrap this up. Believe our salt and 22 properties. 22 Parada. Taking a break. Taking a break.